Hello friends, today I am going to talk on multivariate outlier detection. This is one of my project interests that I did in 2015 with Johnson & Johnson at New Jersey. So I'll start with the data. 3 GB of sample data is extracted from machines producing molds for contact lenses. Raw data consists of around 120 variables. Sensors are recording 5 data points every second. So this is the general description of the data. The requirement was the need is to judge whether the machines are running out of control, generating outliers and causing low quality production. So I was given the data to analyze 3 GB of data and was asked to give a report on the condition of the machines, whether they are generating too much of outliers or not. So I dropped the constant columns and the junk columns with null values, and then I for collinearity I dropped several columns, and from 120 variables it came down to 23 variables. These are the attributes or the variables, 29, 23 of them, and these are used for data analysis. Something about the model. So for outlier detection I used Mahalanobis distance, which says d square equal to y minus mu transpose sigma inverse y minus mu, where y is the matrix of the input records, mu is the mean value, and sigma is the variance covariance matrix. The problem with Mahalanobis distance is that in many cases sigma turns out to be singular and there is no sigma inverse possible. So canonical dimension reduction is used to deal with the singular variance covariance matrix problem. I used the 23 variables and that gave me a non-singular sigma. And Mahalanobis distance when scaled follows f distribution, which is used to find the p-values. So n minus p times n divided by n square minus 1 into p, where n is the number of records and p is the number of categories, the number of the variables. D squares follows f distribution with degrees of freedom p and n minus p. So this is used, Mahalanobis distance is used to find out the p values, and this is the chart of the p values. P value came out to be 1 for 20% cases, for P value came out to be 0.95 for 10% cases, P value came out to be 0.9 for 7% cases, P value came out to be 0.1 in 3% cases, but P value between 0 to 0.05 has 7% of cases. So my suggestion, my analysis was in 7% cases the machine is producing outliers. So if you want to improve the quality of the product, quality of the output of the machines, you need to look at these 7% cases. So that was my suggestion. Later I drew the map of the graph of the outlier percentages in the data and used lead regression to predict the predicted outlier percentages. Predictor of first window is used to predict the values in third window. So that is the lead regression, general lead regression, and this is the fitted values. The blue line is the actual outlier percentages every 120 minutes, and the days are running from Tuesday, Wednesday, Thursday, Friday. And these dotted lines are predictions of the outliers, which more or less match the actual. I'll stop here. Thank you.